Recently, at the National Aeronautics and Space Administration's headquarters, an alert system displayed a strange signal no man has ever seen. The signal was transmitted by a massive object to Earth, and this strange signal currently baffles scientists and astronomers because they have no idea where it's from or why it was sent. What signal could this be? Could it be a message from aliens trying to communicate with us? Join us as we explore how NASA's alert systems warn that a huge object started sending Earth signals. We all know that the final frontier is so vast, scientists and astronomers have not been able to explore up to 10% of its entirety. However, the little observed is enough to send shivers down our spine. The possibility that life forms that aren't related to humanity will be found in space is one of the most discussed topics, and it is in fact one of the driving factors that fuels space explorations. But humans can't keep going up to the final frontier, and that led to the invention of telescopes and other NASA alert systems that can be used to detect any activity that can confirm the presence of alien life forms in space. These tools have helped scientists and astronomers know more about space and its entirety, but one that baffles scientists in a different way is the radio signals detected up in space coming from a huge object. After these radio signals were captured, scientists' studies and calculations showed that NASA's alert systems detected them from a galaxy located almost 9 billion light-years away from Earth. This was a weird discovery, yet it was also a record-breaking one, as that was the first time a signal like this had been detected from such a long distance. According to a statement from the Indian Institute of Science, the astronomical distance over which such a signal has been picked up is the largest by a large margin. It is also the first confirmed detection of strong lensing of 21-centimeter emission from a huge object. Could this signal be from an alien civilization residing in this faraway galaxy? Is it like the alien transmissions detected from our nearest star system at Proxima Centauri? The alien signal detected from Proxima Centauri was meant to be kept a secret until it leaked out to the public. When this information leaked out, nobody would have thought it was the same Proxima Centauri, a star too dim to see from Earth with the naked eye, which is nonetheless a cosmic stone's throw away at just 4.2 light-years. This is the same star that has alien life forms transmitting signals down to NASA's alert systems, and we wouldn't have known until the details obtained from archival data got out to the public. The archival data showed that the signals seemed to be emitting from the direction of our neighboring star, and as a result cannot yet be dismissed as Earth-based interference. This cemented the opinion that this detected signal had to be a transmission from some type of advanced extraterrestrial intelligence, because it also had a techno-signature. And apart from its techno-signature, this signal from Proxima Centauri is regarded as one that has to be studied carefully. A scientist named Andrew Simeon from the University of California, Berkeley, and his team studied the detected signal. The transmission has some unique properties that can cause it to pass many of the team's checks, but it's still a mystery. Another reason this signal raised more curiosity is that it has a very narrow radio spectrum band, 982 MHz to be precise, which is an area usually devoid of transmissions from human-made satellites and spacecraft. We are not aware of any natural way to compress electromagnetic energy into a single bit in frequency such as this occurs, Simeon said. Perhaps, he continued, some as yet unknown exotic quirk of plasma physics could be a natural reason for the tantalizingly concentrated radio waves, but for the moment, the only source that we know of is technological. NASA's alert system detected this transmission in conjunction with a $100 million project named Breakthrough Listen. It is a project led by Simeon and supported financially by billionaire Yuri Milner under the canopy of the tech billionaires at Breakthrough Initiatives. The aim of this multi-year endeavor, which started in 2015 with a star-studded announcement graced by Stephen Hawking and other space science luminaries, is to observe the radio telescopes worldwide to search the skies for proof of technological civilizations. That pursuit, of course, is more popularly known as the Search for Extraterrestrial Intelligence, also known as SETI. Till today, no such evidence has convincingly been discovered, even though more than half a century of modest but steady SETI activity has been ongoing, with any potential transmissions almost always ruled out as originating from satellites orbiting Earth or other human-caused interference. Now, discovering such a signal is just another bizarre yet fascinating thing to observe. Jason Wright, a SETI-centric astronomer at Penn State University in Pennsylvania, made a comment on the detection of this signal, saying, "If you see such a signal and it's not coming from the surface of Earth, you know you have detected extraterrestrial technology." Discovering this signal was not something scientists expected, but what they weren't aware of was that this development had started as far back as April 29, 2019. It was during this period scientists and astronomers partnered with Breakthrough Listen and started collecting data. This data collection process was what later revealed the alluring signal. A team had been working with the Parkes Radio Telescope in Australia to observe Proxima Centauri for any signs of flares coming from the red dwarf star in order to understand how such flares might disrupt Proxima's planets. The system hosts at least 2 worlds. The first, dubbed Proxima b, was discovered in 2016 and is almost 1.2 times bigger than our planet. It also moves in an 11-day orbit. Proxima b can be found in the star's habitable zone, a hazily defined sector in which liquid water could exist upon a rocky planet's surface, as long as Proxima Centauri's powerful stellar flares do not become more powerful than it already is. Another planet, the roughly 7 Earth mass Proxima c, was found in 2019 in an ice-cold 5.2-year orbit. As the team of scientists and astronomers used the Parkes Radio Telescope, they studied the star as part of their stellar flare research. But as is routine within the Breakthrough Listen project, they also flagged the resulting data for a later look to seek out any signals that would show the signs of extraterrestrial intelligence. This task was given to a young intern named Shane Smith. He was in Simeon's SETI program at Berkeley and an undergraduate at Hillsdale College. Smith began the job given to him by filtering through the data, but it was not until 4 months later that he discovered the curious narrowband emission right at 982.002 MHz and hidden in plain view in the Proxima Centauri observations. From that moment, everything sped up with good reason. This discovery made by Shane was so baffling yet intriguing. The scientists on the team could not hide their joy at this unusual breakthrough. Sophia Sheikh, a scientist from Penn State University who was in charge of the subsequent analysis of the signal for Breakthrough Listen, said in a comment, "It's the most exciting signal we've found in the Breakthrough Listen project because we haven't had a signal jump through this many of our filters before." Sophia was also the lead author of a published paper about their work. The team eventually referred to the signal with a more formal name, BLC-1, which stood for Breakthrough Listen Candidate 1. To awaken any SETI researcher's interest, a signal must first cope with a bombardment of simple automated tests to rule out obvious terrestrial interference. Hundreds of candidates, however, frequently pass this phase and are separated for further investigation. From there, almost all will be dismissed as errors or mirages. It could be classified as an excess of static that fooled the winnowing algorithm, removing them from consideration as any signals from aliens. Except this one, Sheikh says. Based on this fact and the previously obtained data, Sheikh and her colleagues returned to the telescope that had looked at Proxima several times in scans totaling 30 minutes over a week. Breakthrough Listen and NASA's alert systems incorporate a procedure called nodding. This is the process where the telescope will spend time positioned at a target and then a similar amount of time looking elsewhere in the sky to check and be sure that any potential signal is truly coming from the target and not probably due to someone microwaving their lunch in an observatory's cafeteria. Well, the former was the case in this signal and Sheikh confirmed it. In 5 of the 30-minute observations over about 3 hours, we see this thing come back. Sheikh said that was a hint that showed that the signal truly emanated from Proxima Centauri or some other deep space source in that part of the sky before it made its way down to Earth. One might think this case is closed already, but that just left room for theories and more postulations about the signal coming from an alien world. While a natural cosmic source may seem unlikely, it cannot yet be kicked out the window. And as unlikely as a natural explanation might be, an unnatural explanation of this phenomenon, such as aliens, is even less likely still. As a result, almost every member of the Breakthrough Listen team staunchly insisted that the chances of this being anything other than terrestrial interference are exceedingly remote. The possible thing is that it's some human cause, says Pete Warden, executive director of the Breakthrough Initiatives. And when I say most likely, it's 99.9%, he concluded. And that rational skepticism extends all the way to the desk of the tech billionaire Yuri Milner. When we launched Breakthrough Listen with Stephen Hawking in 2015, said the tech billionaire, it was understood that the most rigorous scientific approach will be used to analyze all candidate signals. Milner and all the SETI researchers his funding supports fully expect BLC-1 to fade under the project's now intense inspection, but to their surprise, it didn't. Afterward, months of intense analysis and research were kept in store to rule out other possible sources conclusively. At the same time, BLC-1 was reviewed again because while it seemed to come from Proxima Centauri, it did not exactly suit the expectations for a techno-signature from that system. And as it was reviewed, they saw new observations. To begin with, the signal had no trace of modulation or tweaks to its compositions that could be used to convey information. According to Simeon, he said, BLC-1 is, for all purposes and intents, just a tone, just one note, Simeon says. It has absolutely no extra features that we can discern at this point. Secondly, they saw that the signal was drifting. This meant that the BLC-1 appeared to change very slightly in frequency. Now, this had to be divided into the possibility of two causes. It was either an after effect that could be due to the planet's movements, or it could be a moving extraterrestrial source, or a huge object such as a transmitter on the surface of one of Proxima Centauri's worlds. But this drift is the reverse of what one would expect for a signal from a world twirling around our sun's nearest neighboring star. We would have expected the signal to be going down in frequency like a trombone, Sheikh says. Instead, we see what looks like a slide whistle. The frequency goes up. So far, follow-up observations using the Parkes telescope have failed to turn up the signal again. A repeat observation is necessary to confirm that BLC-1 is a genuine techno-signature. If it is an ETI, it must eventually be replicable because it's unlikely it would be a one-off, says Shami Chatterjee, a radio astronomer from Cornell University in New York. If an independent team at an independent observatory can recover the same signal, then hell yes. I would bet money that they won't, but I would love to be wrong. Nonetheless, it remains one of the most intriguing signals found by Breakthrough Listen, or indeed any SETI program to date. One that Sheikh compares to the so-called WOW signal detected in 1977, which some believed to be of extraterrestrial origin. I think it's on par with the WOW signal, she says. More likely than not, however, this is simply some previously unknown source of Earth-based interference, and in a few months we'll likely know for certain one way or another. But even if this signal is unknown, can we say the same about the weird signals that were detected inside the Milky Way? This absurd signal coming from inside the Milky Way is one that scientists became familiar with once they came in contact with it. These signals are known as fast radio bursts, or FRBs. For 14 years, astronomers have counted themselves to be lucky because they have been studying fast radio bursts from outside our galaxy. And then they became luckier with the recent signal they got. Two ground-based radio telescopes made this discovery as they detected an intense pulse of radio waves within the Milky Way. It was the first time a fast radio burst had ever been found within our galaxy. And even though it lasted just a millisecond, it was almost impossible to miss. Situated about 30,000 light-years away from Earth, the fast radio burst was detected by the Canadian Hydrogen Intensity Mapping Experiment and the Survey for Transient Astronomical Radio Mission 2. Finding these FRBs was actually not a mission scientists and astronomers embarked on. It was discovered by accident because, according to the assistant professor of physics at the Massachusetts Institute of Technology, Kiyoshi Masui, he noted that CHIME wasn't even looking in the right direction, and we still saw it loud and clear in our peripheral vision. STARE 2 also saw it, and it's only a set of a few radio antennae made out of cake pans, he concluded. This discovery was also a record-breaking one, as it was recognized for being the most energetic radio blast that scientists and astronomers have ever recorded in the Milky Way. But what made it more intriguing is that scientists are now getting nearer to discovering the fast radio burst origin. Scientists are happy about this moment and discovery because up until now, fast radio bursts have been billions of light years away, which makes them a lot harder to study. Even a doctoral candidate in physics, Pragya Chawla from McGill University in Canada, made this in a statement. Now there's one close by. The first time fast radio bursts were initially discovered was in 2007 when Duncan Lorimer and David Narkovich were studying data obtained by the Parkes radio dish in Australia. Yet one of the major problems with detecting fast radio bursts, besides most of them being so far away, is that they are so fleeting. Ideally, astronomers would discover an object and focus one or more different telescopes on it, but the ephemeral nature of these bursts removes any such opportunity. Indeed, despite being 100 million times more powerful than the Sun, releasing as much energy in a few thousandths of a second as the Sun in 100 years, these fast radio bursts have been present and also vanished, all in the blink of an eye. But despite such challenges, astronomers have built up a bank of knowledge about fast radio bursts. They are bright flashes of radio light lasting for microseconds to milliseconds. All sky searches for them also postulate that thousands of these bursts occur in the sky daily, Chawla added. We also know that most of them come from billions of light years away. But while dozens of models have been proposed to explain the origins of FRBs, with progenitors ranging from neutron stars to white dwarfs to cosmic strings, they've remained a mystery. Much human time and energy have been devoted to working out exactly what they could be. And with the discovery of this weird signal, the tools that detected this signal proved essential, especially the Canadian Hydrogen Intensity Mapping Experiment. Located at the Dominion Radioastrophysical Observatory in Canada, it's a novel radio telescope with no moving parts. It possesses a high mapping speed thanks to its 200 square degree field of view and wide frequency range, 400 MHz and 800 MHz. Most radio telescopes aren't able to pinpoint the location of an FRB well enough to associate it with a known object. Those that can localize FRBs with great precision usually look at small patches of sky and can only study a patch about the size of the full moon. They are not able to monitor several known magnetars at once, Chawla said. The Canadian Hydrogen Intensity Mapping Experiment, however, observes an area about 500 times larger, and it can therefore monitor all magnetars situated in the northern sky every day, permitting us to discover a burst as rare as this one. It infuses its localization capabilities with a large sky area, allowing us to detect and associate this burst with a known object. The Canadian Hydrogen Intensity Mapping Experiment has been so extraordinary and, as a result, has quickly become the main observer of fast radio bursts, with a correlator supercomputer processing 13 terabits of raw data per second to create a radio map of the sky. Our mission to detect far-off FRBs has improved dramatically over the past few years, Masui said, and it's set to get even better. Scientists geared these improvements at McGill University, and they revealed the development of a new system for sharing the vast amounts of data generated by CHIME. This means that scientists would use a standardized language for talking about astronomical events called the Virtual Observatory Event. Astronomers can transmit information about fast radio bursts, several of which happen every day, to observatories around the globe in real time. This recent development might not only be for the purpose of fast radio bursts, but for any other unknown alien signal detected from space. Do you think these alien signals are real? Let us know your thoughts in the comments section below.